Hi, my name is Cole Williams, and I'll be briefly going over the code for my programming concepts project. So this is a lot of dialogue just in the beginning, and then we've got the rules. So you can type 1, and it will only read the rules if rules equals 1. So if you input 1, it'll read the rules, and then anything else, it will just skip them. Some more dialogue, and then here's for the character inputs and the wall color input. So these are basically all the same. I've got check equaling 0. So only if you type 1, 2, or 3, for instance, this one is blue, red, or random, the check will then equal 1, stopping the while loop. However, if you type anything other than 1, 2, or 3, it will fprintf invalid choice, please try again, which will then run the while loop again until you choose a valid number. It's the same thing for the other two inputs. And then basically this is my parameter section, which is just turning the character color, character shape, and wall color into usable values for the code. So this, for the color of the character on the wall, it's turning these into a RGB color code. And same for random, it's using the rand function to make a 1x3 matrix, which is in the same format as a RGB color code. And then for color character shape, 1, 2, 3 is just deciding what shape it is, and the S, O, or D is for square, circle, or diamond. And now we've got all the inputs defined. This is a matrix that I've made for the white spaces of all the subplots. So, like for instance, this white space is denoted by this first row, where the first 12 values are the X, and then 13 to 24 is the Y. So this is the initial setup where basically we're just running through all the plots and turning them black and setting the X and Y limits. And then this is just taking the first subplot and setting the wall color that's been chosen, as well as plotting the marker at 1, 5 with the correct shape and color that was chosen. This is also very important. This is how I'm keeping track of where the player is. So I've got you always start out at marker X equals 1 and marker Y equals 5. So next thing I've got in my code is the key placement. So the key will be randomly placed in one of these squares. And the way I'm doing that is I've got a matrix of all the possible locations for the key. So the first number is always the subplot, where the second and third numbers are the X and Y. So this is really just taking a random row from this K matrix, and then these are just extracting from the given row. So let's say I were to randomly choose this row, then the key zone, key X and key Y would be subplot 6 at X and Y being 5, 3. So now to the movements. The way I'm actually keeping track of the player is with the X and Y. And essentially, based on what direction I'm moving, so I have them organized in north, south, east, and west. And I'll just kind of talk about east because that's actually a direction I can go right now. So if I were to set this all up, essentially the way I'm keeping track is first, if I were to choose 3, if I were to choose east, it's first checking to see if I'm in a zone, if I'm in a subplot that I'm able to move east in. So if I'm in any of these 6 boxes, I can move east. However, if I'm in these boxes, I cannot move east. So if I'm in these 6 boxes, I can move east. However, I have an else statement where if I'm not, it says you cannot move east. So try again, which will restart the while loop. And in order to get to the edge of this box, I've basically got I running from marker X, so this X location, to the edge, so 6, running at 0.2 increments, and it's moving every 0.05 seconds. And then this ends, so it's bringing it to here, then that for loop ends, then this is essentially turning this box black. So you can see if I move east, it moves to that subplot, turns this black, and then the next for loop here is essentially doing what we saw in this box. So it's now taking zone, so it's taking the subplot 1, and it's filling this all black. But then what it's doing is, based on the direction, it will change the zone that you're in, as well as change the zone X and zone Y. So if you're moving east, the zone will always be +1. It'll be -1 for south. I'm sorry, for west, and then north will be -3, and south will be +3. So here I'm redefining zone X and zone Y with the Z matrix for the Y space. So I'm continuously plotting the Y space and the marker. And then also in between here, I've got if you're in the same zone as the key, and if you have not found the key yet, it will also be plotting the key. So that allows you to find the key, but it also allows the key to not reappear if you've already found it. So at the end of each direction, I also have count equals count +1. So it's continuously tracking how many moves you've made. So as I said before, like moving west, now it's doing zone -1. And I also forgot to mention that for marker, since your X is continuously changing, so you've got like for instance, your X value here is 1, but your X value here is 3. So it's now adding 2. But if you're going west, it's going to be subtracting 2 for your X value. And the same kind of thought process for north and south, where it's taking your Y and adding 2, because you say you'd be at Y3 and then you'd be at Y5, and then if you ever move north, like let's say, or if you move south, you're going from Y3 to Y1. So no matter where you are, all the logic still applies. So as long as you know what zone you're in, which I do, everything carries over. So now at the very end, once you find the key, it'll see if the zone that you're in equals the zone the key is in, and you have not found the key yet, it'll congratulate you for finding the key and tell you to go back to zone 1. And also, if the zone you're in equals the zone that the key is in, it basically means you found the key, and the key now equals 1. So none of these will run anymore, meaning the key will never reappear if once you found it. So going down back to the very top, to the part that I skipped, this is the very end. So at the very top of the while loop, if the zone that you're in is 1, once again, and if you found the key, aka key equals 1, then it will turn all the colors, all the subplots from 2 to 9 different colors, and it will repeat that 3 times. So I've got a nested for loop where the nested for loop here is running from 2 to 9 because you don't want your first subplot to change. But it's just taking a random color, same way we set the color of the character in the walls. It's making an RGB code, and then it's just filling the entire box with the code, and it's pausing for 0.1 seconds, and it's repeating that throughout each plot. And then I have like the for loop, like the first for loop is going from 1 to 3, so it's repeating that pattern 3 times. So if I were to finish this out, and if I were to go here, and then let's see, we'll try north, and it said, or we'll try north, and it says you cannot try north, try again. So I'll go ahead and go south, and then I'll go west, and there's the key. So we pick the key up, and then we'll go west again, and then we'll finally go north back home, and once we make it to that spot, it will cycle through all the colors. And it will finally tell you you've won the game after 6 moves, congratulations, and that runs at the very end here, once the while loop has broken due to this loop up here. Because once you finish the game, it will break the while loop, so you no longer have to make any moves, and it'll give you little congratulations at the end. And that's essentially the breakdown of all the code. So thank you.